All right, I see the numbers slowing of attendees rolling through, so that's usually a pretty good indication that everybody's been able to get connected to the audio and video part of this portion. Again, thank you for your patience and flexibility as we get started here, and happy to kick off today's conversation around trusted AI at scale, building secure, observable agent platforms for the enterprise. And I want to talk a little bit before we start about the logistics of the webinar. So this webinar is being recorded. You'll receive an email from Vectara with a link to the full recording of this webinar today. So no worries if unfortunately you have to miss any portion of the webinar. We'll make sure that you receive that recording shortly after here. Every participant in the webinar is muted, but that doesn't mean we don't want to hear from you. So if you have a question during any point of the webinar, I suggest that you pull that question in and go ahead and throw it in the chat for us. We'll reserve about 10 to 15 minutes at the end of this webinar to address any of the questions in the crowd, and we're happy to hear from you, but don't feel like you need to save that till the end of the webinar. With that, I'm glad to get everything kicked off today. And again, thank you for joining us for this topic today. It's a huge pleasure of mine to introduce our two speakers today. As they say, the doctor's in. We have Dr. Tallat Shafaat, who's the founder and CEO of Vectara, who's joining us today. And also as well, we're joined by CEO of OPAQUE, Aaron Fulkerson, and really looking forward to the level of both technical expertise and kind of industry enlightenment that both of these participants bring to the table. But without further ado, I'll let them tell us a little bit more about why they're here and what we're here to talk about today. So what I'd like to do is to just start us off is to open up the floor to let our two panelists tell us a little bit about their company. And as founders and CEOs, what were the hard problems that they really tried to attack when starting these companies, and what have they learned along the way? So actually, since Aaron's our guest, Aaron, why don't you get us kicked off today?
Sure. Thanks so much for having me, Sean. And nice to see you again, Tallat. Always a pleasure to spend time with you. So I cannot take credit for being a founder of OPAQUE. In fact, the founders of OPAQUE are quite nerd famous. The founders, or the technology, the company spun out of UC Berkeley's RISE lab. And the founders are Ion Stoica, who's the creator of Databricks, along with many of the foundational AI infrastructure technologies that are used by everybody from Anthropic to OpenAI, things like VLLM, Ray, of course, Spark, as well as OPAQUE. And then the other founders are Dr. Rishad Padar, who's our CTO, and then Dr. Raluca Edapapa, who is a Grace Hopper Award recipient for her research in security and AI. And she, in addition to being a co-director at the Sky Compute Lab, and a professor at UC Berkeley. She is the researcher responsible for AI security and privacy at Google for Gemini and DeepMind. So cannot take credit as a founder. I am the CEO. And what OPAQUE was founded to do, or what it was created to achieve, is the folks at UC Berkeley who started this recognized that AI, in order to achieve its full potential, would need to be connected to the most sensitive systems, the most sensitive data. And in order to achieve that, there needed to be a mechanism or a technology in which you could enforce that the agents followed the rules that are expected of them and prove that they did follow those rules. And the reason why what OPAQUE has built, and this emerging category of confidential AI, why it is one of the top three most important technologies of the next decade, is in order to achieve the true potential of AI, you have to be able to prove that the agents followed the rules. And every single day we know there's new evidence in the news that software-based governance and guardrails fall short. I'm excited to be here and always eager to be with Tallat. I know you guys are really delivering the best implementation for confidential agents, particularly around enterprise grounding and enterprise data. But Tallat, tell us about Vectara so I don't fumble what you guys are are doing. I'm just really, really excited about. I know how strong your technology is, so you tell us.
Thank you, Aaron. Hi, Sean, and thanks everyone for joining today. Basically, our thesis of the company, before starting this one, I was working at Google. And as folks know, like Google came up with the transformer architecture, and they released one of the popular earlier models was BERT that increased the search quality for Google significantly, right? So the thesis of this company was how can we use these kind of transformer-based models in enterprises outside Google. Training some of these foundational models is extremely expensive, but using them is not as expensive, right? So the thesis was, how do we take this to the masses? And that's what we started off with. So initially, we used these models for strong retrieval. So we were using like vector databases and hybrid search, all that kind of stuff to give enterprises something that's way better than lexical search. And this was back in like early 2020s. And that expanded as we grew to stuff like RAG and now a whole agentic platform that you can use for different use cases. And one of the use cases is basically where enterprises have a lot of data and they want to run agent on top of them, whether it's for answering questions or something like that. So that was the thesis of the company, and that's where we are now. So
You know,
Fantastic.
the significance of what you just said, which is enterprises have a lot of data. That's of course you making it possible for them to use the data within these agentic workflows to get value out of it. You guys are so exceptionally good at that. And it's so important to note that whoever controls the data controls the industry. But if that data is trapped away somewhere where it can't be retrieved as part of a agentic workflow, it's of no value to the organization. And then similarly, on the opaque side, if that data gets leaked into somebody else's models or somebody else's um, enterprise, they will control that entire industry. So you guys are unlocking it to make it useful. Opaque is making it certain that the data stays under the sovereignty of the enterprise that owns it.
Absolutely, Aaron, and couldn't have said it better myself. I think that one of the things that we've seen over the last 2 years is the conversation expanding, not just around how are we going to leverage AI, but how are we going to leverage AI in a smart, responsible, trustworthy way. And I think we're going to talk more about barriers that companies see, but I think that's a pretty common thread in all of this stuff. We were just out recently, a couple weeks ago, out at the HumanX conference here in San Francisco. And I'll just say that, the AI market is crowded. Huge showroom floor, lots of vendors there doing everything from AI for HR, AI for legal, self-made and kind of packaged up AI agents, full platforms, optimizations around infrastructure. And so, kind of in this crowded market, I think what in your mind really makes what your company's doing different and offering is different and based on what you set out to do or maybe what you learned along the way? And how does that really matter? How are they measuring the business outcomes associated with these new capabilities that we're bringing to market? And again, love to start out with you, Aaron, as our guest and go from there.
Sure. So, we just had our iPhone moment with AI agents, which was OpenClaw. And it really ignited everybody's imagination about the potential of using AI agents. But in reality, everybody who's adopting AI agents is really in the sandbox stage where they're doing some early pilots. Of course, Vectara has many great customers that have moved into the powerhouse stage, which is they're actually pulling in the data from existing data repositories and getting it into production. Um, Now, I'm not speaking specifically to Vectara, but I'm speaking against the industry at large. What we've seen is most enterprises are stuck in that powerhouse stage where they get something up and running, but it's in customer service or it's connecting agents to systems that are not sensitive or data sets that are not particularly sensitive. And in order for them to realize the full potential to achieve powerhouse status, real differentiated value from AI agents and AI systems, they have to connect it to their most sensitive systems. And in order for them to achieve that, the software policy layers, particularly in regulated industries or large enterprises, are insufficient. Even the world's best at building these software governance or software guardrails, let's take Google Gemini, uh, continues to prove that you cannot constrain these agents at a software layer. You have to provide hardware enforced governance. Now, I say Gemini, what am I referring to? Look no further than the recent news earlier this year, where a gentleman in Florida, this is a 40-something-year-old gentleman who's gainfully employed as the vice president of a logistics company, succumbs to AI psychosis, falls in love with a Gemini agent, and starts going on secret missions, or at least he thinks he is, to prevent the Department of Homeland Security from importing a killer robot. So the point I'm making here is what differentiates what OPAQUE is doing is you have to provide rules that are hardware enforced for these systems and verifiable. And you don't have to take my word at OPAQUE for this. The entire technology landscape has already moved in this direction. So this is what Apple, Google, Meta, Microsoft, TikTok already do internally for their systems. And then NVIDIA at GTC this year, Jensen put confidential and hardware enforced, or what he keeps referring to in every one of his session about verifiability. He's talking about hardware enforcement and confidential at the center of his entire 5-year product roadmap. So for us at OPAQUE, our key differentiation is, thankfully, due to the brilliant minds of our founders, they spotted and understood that the non-determinism of these systems requires a new kind of trust layer, and that trust layer has to be grounded at a hardware level. The good news is you don't have to have any special hardware. All of this is already available in all your cloud providers. It's already turned on.
And Talat, you want to explain a little bit about how Vectara's approach to solving some of these problems is a little bit different from other solutions?
Yes. So thanks for that, Sean. So basically, what Vectara provides is a end-to-end agent platform for enterprises, right? So these are managed agents that run on the server side that you can operate via APIs. And we are model agnostic. So we come in with our own machine learning models that we have fine-tuned for different cases like embeddings, re-ranking, whatnot. But then you can use any model that you want, right? Open source models by some that Aaron mentioned, like Gemini and whatnot. Um, and what we focus a lot on is how do you provide the right context to the agents to do the right thing, right? So we spend a lot of effort on how to deal with multimodal data that has images, text, charts, and tables and whatnot. And then in the enterprise level, like Aaron mentioned, one of the most important thing is how do you deal with security, right? These companies, their reputation is at risk. All the data of their customers at risk. Their IP is at risk. So we collaborate with companies like OPAQUE for that. And then there are other features that enterprises need all the time, which is like observability and auditability, tracing, how to deal with large amounts of data. So we specialize in that. Having said that, like Aaron mentioned, like a lot of these companies are scared what's going on right now, right? As long as you control your data, you still feel safe. Once you give the data to, let's say, a cloud provider or a machine learning company, you don't know what's going to happen. We recently saw that Anthropic's Claude, like a lot of their source code got leaked, even though their policy says don't leak the code, right? But that did happen. So mistakes can always happen. It might not be intentional, but once your data leaves your premises, you have no control over it. So while we had our SaaS service and our VPC service, we saw a lot of push from our customers. What can we do on-prem? So today, one of the biggest differentiators we have is we are available on SaaS as well as customer VPCs and on-prem. So you get the same agent harness, same features in any environment that you feel comfortable with. And then you can use whatever models your company allows to run. And that's what we specialize in. So there is no lock-in with an environment, there's no lock-in with the models. And what we see is that since we are a horizontal like agent platform that they can use to build different kind of agents, companies be more comfortable with that because they do not want to buy 10 different vendors for 10 different use cases, right? So they just come in with one solution and they can build whatever use cases they want to build. With the code getting cheaper and cheaper to write, they can build custom solutions for any use case they want. Second is they can just throw in their data once and then used via APIs used as in different applications, right? So that's where we differentiate and we have gotten a lot of traction as well.
Excellent. So I feel like we're kind of wading into some of these topics around why we're maybe not seeing some of the explosive growth in agent system, although I think we see day by day more willingness to, get out of that kind of or get into that kind of powerhouse stage where we're using real data and actual domain specific things, whether that's by addressing it on-prem or really understanding that the data is locked down and secure. Aaron, you mentioned NVIDIA. One of the moments at NVIDIA was, Jensen Huang in his keynote laid out this vision of 100 AI agents per worker. And I think that's like one side of the pendulum, right? The very optimistic side. Then on the other side, you have the MIT report about 95% of projects failing. Other reciprocal reports saying that, large organizations in the middle of the US are really struggling to get, some of these systems into production. So, in both of your experience, what do you think are the biggest challenges standing in the way of getting some of these projects into production and really seeing kind of like verifiable business outcome? And Talat, we can start out with you. I know we've seen some great expansion with on-prem deployments, but how did we unblock some of those hesitations for users?
Yeah, I think so basically one of the biggest way to alleviate on-prem is companies, some of them they want air gaps, right? They do not even want our DevOps people to have access to the installation, right? So the best, like the most the enterprises that are most like sensitive about their data, for example, they have their IP there, they go with our air gap solution where nothing leaves the network basically, right? But then if you look at more challenges for production, I think you can just build a toy demo of an agent, including retrieval, in half a day, right? But once you go to production, it's a completely different game. Maintaining the same accuracy with the complex data sets you have in production, the complex kind of queries that the users ask, the complex kind of like the large amount of data that these folks have, it just gets more and more complicated. The security aspect, like I don't think we can emphasize that enough. From what Aaron mentioned to prompt injection to data leakage, how do you deal with those, right? How do you deal with hallucinations? And another big challenge that companies these days are facing is in drifting agent performance, right? So when you launch something, an agentic solution, it performs well, but in a couple of months, all of a sudden it's not performing well, right? There can be 50 reasons for that, like the data changed, the model capabilities changed, the context changed, right? So how do you deal with those? How do you ensure that over time your agent's performance is not degrading and in fact it is improving? So all these kind of challenges companies need to be aware of then when they go to production.
Thanks a lot. I'll jump in on that too, Sean. I'm sure you're about to hand it over to me. The Jensen statement about each knowledge worker having 100 agents, like that's not fantasy, right? That's where most of us in the field are today. In fact, I have an agent that writes about an agent harness named EXO that writes about his experience managing a swarm of agents for me in my work, and it blogs on my personal blog about its experience. So this is a reality today for most of us who are in tech. To your point about the MIT research, Talat just nailed exactly why the majority of these projects don't achieve real meaningful ROI is because they aren't using a technology like Vectara that makes their complex data grounded well in the AI to deliver real meaningful results. So it ends up starting out as a pilot, like that sandbox stage I mentioned before, and it never actually matures into the powerhouse stage, or maybe it moves into production of the powerhouse stage, but it's basically garbage. Um, that's one of the key reasons. But the underlying cause for that in most cases is these systems leak data. AI agents leak data. It's just a fact of the current architectures. So we provide on opaque.co a research paper in which we worked in collaboration with our co-founders at UC Berkeley and our customers, Anthropic, Accenture, and ServiceNow, and others. And we mapped out an AI leak map. This isn't about hackers. There's 46 different vectors that cause data leaks within an agentic system. 46. And um, the point of this is it is a greater than 0% chance that given current architectures, your agent will leak data. Let's say it's a very conservative 1% probability, just 1%. At 100 agents, using the Jensen example, the math behind that, combinatorial math, is 60% probability that you will leak data from 100 agents. At 1,000, it's 99.9%. So we're not even contemplating hackers or attackers. It's just a function of the current architectures. And Opaque solves 80% of those 46 leaks. We don't even solve 100% of them. It's 80%. So we dramatically shrink the surface area for data leak. So the biggest challenge isn't agent intelligence. It's really about agent identity and also about agent containment. So most enterprise today, they're deploying agents the same way they deployed microservices in the past, 10 years ago, 15 years ago. Hierarchical access controls, role-based permissions, perimeter trust. Those models do not work and scale in systems involving AI agents. These are operating at machine speed with human-like capabilities. They're non-deterministic. However, if you don't adopt AI agents, you're stuck. And the challenge of that is twofold. One, competitive. While your competitor is reinventing itself and their entire business with AI agents using their proprietary data, and you do not, you're Kodak. You're out of business. So the second part of this is um, defensive. So IBM's 2025 breach report says 13% of organizations have already suffered a breach of an AI model or application. So enterprises are blocking nearly 60% of AI transactions today because they can't guarantee privacy. So this isn't just a security cost, this is a revenue and innovation cost. So we have to re-architect these systems so that you can be competitive and so that you can get access to the most sensitive data and ensure that it doesn't end up in somebody else's model. But key point here, right? The agents' intelligence and capabilities today are so far ahead of the architectures. So it's not like we're failing because of the agents, but we're failing because of the underlying architecture and the ability to process enterprise data or connect to the most sensitive data and systems.
Excellent, Aaron. And just to kind of really quickly double click, because I think you had some fascinating points about the IBM research, the math behind the surface vector, especially when people are prophetalizing that, like, websites will go away, agents will be doing everything, right? So, like, 100 of those mistakes at that type of scale when businesses are trying to transition becomes deeply problematic. Now, you talked a little bit about the cost not to adopt, right? Competition, competitive pressure, accelerating innovation. But what is the cost that a business can incur if they rush one of these without thinking about, data security without these safeguards in place to address data leakage?
Toys R Us. So for those who are unaware, Toys R Us launched on Amazon, and it actually led to the bankruptcy of Toys R Us. So it was one of the first white label e-commerce businesses that ever launched on Amazon. And as a result of that, the data that Amazon was able to generate literally put Toys R Us out of business. So you see this similarly around Amazon Basics. You put your product on Amazon, Amazon has all the data about the sales, transactions, demographics, profit margins. They then launch an Amazon Basics product and put you out of business. So whomever owns the data owns the industry. And one, I completely agree. Like, you have to reinvent yourself with AI agents. It's not an option. However, if you do so, and you don't take effort to use modern architectures like hardware enforced containment, cryptographically enforced identities of workloads, you will leak your data, and it will end up in the hands of probably a frontier model lab who's going to launch a business and sell products for pennies on the dollar or dimes on the dollar. So I'm a huge AI optimist. The good news is that there's an entire ecosystem that has emerged over the last 2 years, building on technology that's been around for 10 years to solve this problem. So you can set rules that you expect your AI agents to follow. They're enforced at a hardware level, and you can verify that they were followed. So, yeah, this is once you open that Pandora's box and your data gets out, there's no going back. It's not like it used to be where, well, there's so much data out there. What's the real risk? You know, even the notion that the frontier model labs aren't training on your data is preposterous, because it's the metadata that you're using and interacting with their models is all they need with AI to generate your data from the metadata to train their models. So it's again, like there is a path forward here. I'm not like a naysayer. There is a path forward for you to be able to innovate with AI agents. It just has to be grounded in hardware enforcement.
Yeah, 100% agreed, Aaron. And just to extend that, like if you look at so companies have a lot of pressure right now that they need to do something with AI, right? AI is already so much powerful. So what can you do? So a lot of people, they are pushing forward with solutions with AI, even if they don't have all the bases covered, right? And this applies to smaller enterprise, but also to large enterprises. Like if you look at, for example, Atropic's status page, they have so many outages. If you look at search results or question answers you do on ChatGPT or Gemini, they hallucinate all the time, right? In older days, if you would have done something like this, reputational damage would be significant. Like it would be at a place where you could not recover, right? So these days, people are more forgiving to agents in AI. What they're not forgiving is data leakage, right? There's no way any enterprise will allow you to do that. If an agent is coming up with something that's like oh it produced code for me that is not 100% correct, I just need to change one line to make it correct, that's bad, but that's for maybe a little bit forgivable. At least that's what people are doing right now. Data leakage, no way, no way. Enterprises, for them this is important. They have their IP there, they have their customers information there, they have their own statistics there. There's no way they can get away with leaking that data, and they know this, right? So that's why there's a lot of push to the technologies that Aaron mentioned, both like encryption at runtime. How do you deal with these things? On-prem, air gap, everything combines to protecting the data for enterprises, and that's not going to go away. So you need auditability, you need governance to make sure that you are in control of your data.
Yeah, if you aren't using this kind of cryptographic enforcement, you notice I'll talk about verifiability, hardware enforcement, cryptographic enforcement. I'll use all of these interchangeably. They're all building on the same like primitives from the silicon. So Intel, AMD, NVIDIA, they all produce confidential capabilities that are exposed through your cloud vendors. You don't have to understand what's happening in the hardware. But if you aren't using these techniques or uh, putting on premise air gapped, you're betting your future, the future of your company on hope, prayers, and lawyers. And once that data gets leaked out into somebody else's AI model, there's no turning back from that. So enterprise AI security today is basically hope, prayers, and lawyers. And every week that goes by, we're seeing another example of, oh, well, software governance is insufficient. So we're replacing hope, prayers, and lawyers with math. That's what OPAQUE does. It's mathematically enforced from a hardware root of trust. And I love what Vectara is doing for your customers, not only delivering higher quality results with the really pioneering technology around grounding with enterprise data, but the fact that you're doing it on-prem in an air-gapped environment where necessary, which of course brings us to the next topic you're going to get into, Sean. Go ahead.
Yeah, absolutely. I think let's dive a little bit further into the infrastructure. I mean, it's clear infrastructure spend for AI is through the roof. You see companies, having to lay off workforce just to afford the data center spend that they're looking at. I think recent projections are surpassing something like 100 billion by the end of this year alone. Chip manufacturers, like you mentioned, Aaron, are having some of their best quarters. I saw Texas Instruments had one of its better quarters, this last couple weeks. And so there's obviously a huge amount of interest and spend in infrastructure. Meanwhile, I know if you looked at this about a year ago, a lot of people were saying that the infrastructure patterns were largely the Wild West. Do you think we're starting to solidify on some kind of common infrastructure patterns? I know we have more choices now with the introduction of Kubernetes, with platforms like VMware's VCF that allow you to kind of delegate resources in really cunning ways. But are we starting to see some kind of like solidified architectures in terms of how people are addressing being successful with this? And Talat, maybe you can start us off just based on some of the recent on-prem deployments that Vectara has initiated.
Thanks, Sean. So one of our co-founders, actually the co-founder of Cloudera as well, and Cloudera used to be, like an on-prem solution as well, right? They had a cloud offering, but their main thing was on-prem. And those days, it was pretty difficult to do on-prem. We have come so far from that time, right? So these days, if you want to achieve sovereign AI and whatnot, you have much better infrastructure, right? You have Kubernetes that will deal with 500 things for you, right? Of course, it's still not at a place where it's very easy to do, but this does simplify some of these things. We have a lot of open source inference engines today that you can use for hosting your models. But then you still run into difficulties like how do you optimize them? How do you get the best? What's the right batching strategy? You have so many different GPUs right now. How do you do the compatibility? One set of configuration that was running better in one on-prem deployment is not running the same here because the underlying GPU chain, maybe you don't even have access directly. Maybe you're running over VMware, right? So we come across all of these kind of issues. So while infrastructure has improved significantly, it's still very, very cumbersome. And that's where companies like us come in, where we do manage stuff for you. Even if you want to do an air gap, we provide all the templates that you can just go and install, help with debugging, help with performance issues, how to run inference faster, all that kind of things. But then, of course, there's still problems left, right? Like I think that's what Aaron was alluding to. Like you still need to make sure that even the data that you have there, you're processing in your GPU and your RAM is encrypted, only decrypted when you want to use it, because you still might leak data, right? We always come across bugs, security issues that are still there. So
Yeah, I'll add to Talat. Thank you. The look, it's very clear to everybody that there's nobody, no enterprise is going to be running a mono cloud, right? That's not a reality. There's been a shift over the last 10 years to be running multiple clouds simultaneously because of being able to load balance on costs and keep the hyperscalers honest. But the other thing that we're seeing too is mixed models where every enterprise I talk to is doing a mix of on-premise and cloud. This is true globally. And if you look at all of the silicon vendors, they're accounting for this at the heart. The heart of their entire product roadmap is confidential. So why would you need confidential if you're doing on-premise deployments? So confidential is a set of capabilities to do encrypted runtimes and also hardware attestations, which is what allows you to build hardware enforced governance rules. Right. Now, I won't go into the nerdy details of that, but all of them are providing confidential capabilities as part of their silicon. And all of them are focused on premise and sovereign. I'll just say sovereign, but sovereign often is on premise. Why is that important to them? It's important to them twofold. One, hyperscalers understand that in order for them to serve the rest of the world outside the US, they have to have verifiable privacy because of the US Cloud Act, which allows the United States government to subpoena data from the hyperscalers. Also, hyperscalers all know that they have to provide this kind of verifiable rule enforcement through this hardware attestation in order for them to actually deliver governance of AI agents. But what does this have to do with on-premise? What does this have to do with sovereign? Well, if you're a frontier model lab, let's say you're Anthropic or OpenAI, and you want to distribute your models for the rest of the world, which you desperately want to, because China's kicking ass putting out great frontier foundation models. If you want to distribute your models to the rest of the world and maintain your intellectual property, you have to have verifiable privacy, whether it's on premise or in the cloud. So the significance of what you're describing is what we've seen as I guess, tectonic shift in the market across silicon hyperscalers and frontier model labs to deliver sovereign AI capabilities. Now, by sovereign, yes, largely it's on premise using OpenShift, Kubernetes. That's typically what we see is Kubernetes. Often it's OpenShift that we see in sovereign. Also, what I'm seeing is there's frequently the capabilities with on-prem, with burst capacity in cloud. Regardless of whether we're talking about sovereign that's on-prem or some kind of hybrid model where it's on-prem with burst capacity and some hyperscaler, the fact remains that you have to have these verifiable privacy and governance guarantees. Oh, one other key point, why hyperscalers are so insistent on having these capabilities built into their cloud infrastructure is because their market share is getting eaten up in rest of the world by neoclouds. So neoclouds are doing sovereign cloud deployments with a local operator that's providing local guarantees around data residency, data governance, etc. And in order for the hyperscalers to compete, they recognize that they have to provide this kind of reinforcement from a hardware level. So everything Tallat just said, I'm doubling down on, and I'm just spotting some macro trends around. Yes, there's a big shift to on-prem. We're going to see this proliferate as AI agents move to the edge. And we're going to see proliferation of these hybrid clouds that are on-prem and hyperscalers. And all of this points to a broader macro trend that we're seeing reflected across silicon vendors, hyperscalers, and frontier model labs around this hardware enforced or confidential computing at the core to enable verifiable guarantees at runtime. Oh, by the way, regulators are insisting upon this in the rest of the world too, in Asia, in the Middle East, in Europe, and we have customers in the UAE where this is becoming a policy. It comes online August in the EU AI Act that you have to have these runtime proofs. Sorry, Talat, please.
Yeah, 100% I agree with you. And we even see like a couple of weeks ago, Google announced that they're gonna support Gemini on-prem as well, right? They see the writing on the wall. Like as you go more sovereign, you want control over your data. You're not gonna give your data to these companies like you said, if the data gets subpoenaed, you lose access. A lot of these countries do not want that, right? So push is definitely there, and it's going stronger and stronger by the more news we read about data leakages and whatnot. Right now, a lot of companies, they have hybrid models. Half of the data is on-prem. The data that's not very secretive for them, they're okay losing, or that's based on public knowledge anyways, they're okay. So there are solutions today that are a hybrid of on-prem using SaaS models. But for anything that you want to do serious, anything enterprise, there's a lot of push to go on-prem, yes.
Yeah. By the way, even on the SaaS, like we have customers who are enterprise ISVs, SaaS vendors, who their customers require this kind of verifiable proof of privacy and governance. In order for them to give access to these enterprise ISVs, access to their data, they're like, no, 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 I'm not giving you access unless you can show me verifiable proof that my data stayed within a trust boundary. You couldn't see it. It didn't leak out somewhere. I just got an inbound our team did from a email provider this week where they have new AI features doing search and other new capabilities in their product. People won't turn them on. They're like, nope, we can't use those AI features until you can prove to me that the data adheres to my rules, and it has to be verifiable.
Yeah, all of this talk about governance, Aaron, reminds me about 10 years ago. I was at a DBTA meeting in New York, and a guy that did data governance, or his company did data governance, was selling this vision of having a very strict data governance policy where everything went through a centralized framework. And I was feeling kind of sassy, so I just asked him, with all these cloud providers gaining in popularity, how can you really make people go through all of this centralized governance? It was kind of hairy back in the data governance days. I imagine with the advent of agents, models, infrastructure, it's only gotten even crazier. So what does end-to-end privacy actually look like? Like paint us a picture of how people should think about addressing that.
Sure. So um, there's a lot of these governance frameworks around agents. And unless they take this approach, they are guaranteed to leak. So there is no software layer that can constrain an AI agent. There is a way to do this, though. And the way that it works is there is a category of computing called confidential computing. It has two key characteristics. One is that you can run an encrypted runtime. So the entire workload runs encrypted at runtime. So when your cloud ops, DevOps teams does memory dumps or things occur as just part of the natural course of maintaining your infrastructure, nobody can see the data. So that's privacy, but there's something that's even more important than this. It's a characteristic of confidential computing. It's called hardware attestation. So the same encryption key that's baked into the silicon gets used as a process of signing the components of the stack. And what this means is you can have verifiable proof what ran, where did it run, and what rules did it follow. So this hardware attestation creates a zero trust chain from the hardware all the way out to the agent policies. And that can be used to prove that this is exactly what ran in this workload, all of the components. This is exactly the trust boundary that everything stayed in. I can prove it. And here's the policies that were enforced. If you're not doing this approach of verifiability, you cannot, well, I'll say, you can be certain that your AI agents did not follow the software rules that were assigned to it. They naturally explore domain spaces. This is a function of them being non-deterministic. So that's what it looks like is you're able to run in one of these, like, let's say it's opaque, or you can roll your own. This cryptographically enforced runtime built from a hardware root of trust. It's tamper-proof, it's provable, and it's also what's required by new regulations it's coming online in the US for HIPAA. It's also online in Europe, Asia, and other parts of the world. So like in Germany, this is a requirement for specific public sector and healthcare workloads. In the UAE, where we have customers, it's coming online as policies, as requirements for any public sector or essential enterprises within the nation. And this is just a continuation. One of the key points too is Microsoft, Apple, Google, TikTok, a long list of companies already are doing this internally.
Yeah, if I expand that to the enterprises that we're looking at, right? Like Aaron said in the beginning, like every person will have so many agents of their own, right? Somebody is using one framework, another person uses something else. So now enterprises have the same issues, right? How do you make sure that data is not leaking? So one thing we're seeing a lot of companies do is they gate all the access to all the models, basically. Like they have a single API gateway that any model you want to access, whether it's one cloud provider or somebody else, model provider, it needs to go through this single API gateway. And then you can enforce a lot of policies there. You can do a lot of governance. You can do a lot of like audit traces, logs, guardrails, and you can also play back stuff. Like you want to be able to, at runtime, stop something wrong from going out. But secondly, you also want to be able to audit, like if something bad happened, look back and see what happened, right? So we're seeing this pattern more and more where within an enterprise, companies, they just to have a control of all this, like they have so many engineers, they want to do so much cool stuff with these agents, right? But one has a preference for this open source, one has the preference for that framework. Single API gateway to access all models gives you one way to do this.
Excellent. So I think we're probably good to move on to the audience questions. I would like to invite anybody online to submit their questions at this time. We've already had a couple that have rolled in as we've had this discussion. So Aaron, Tallat, thank you so much. We'll spend a little bit of time to help people understand where to go next here in a minute. So the first question actually came in, Aaron, while you were talking around data ownership. And I think we talked about some of the things on the technology side that address that. How should people, and hopefully I'm reading this correctly, how should people really address the process of that and the people that should be involved in terms of deciding data ownership for things like agents? And Talat, I know that Vectara supports things like role-based access controls, so any comments that you have as well would be good.
You want me to go first, a lot? Sure. Okay. So I spoke with a CIO or CTO, actually, excuse me, from a very large European conglomerate last week who shared with me her frustration that she can't ship. She's like, it takes me 6 to 8 months going through different approval processes, filling out surveys, answering questions for me to get even the most basic things done, just to get access to the data that I need to do my job. That's not sustainable. That's a nightmare. So what AI builders need to be able to do is they need to be able to define rules and ship. They can't be bogged down in 6 to 8 month protracted back and forth with their internal auditors from InfoSec and compliance. The way that OPAQUE solves this is they can define rules using popular frameworks like OPA, Rigo, yeah. And then they can provide a simple web interface to their auditors that they can see all of their workloads. They can see precisely their AI bomb, their C bomb, their S bomb, the policies that were enforced, and they get a cryptographic signature that they can use to verify that that's actually what ran at runtime. So for a builder, it's just like, leave me alone. Oh, you have new policies? You send me the policies. I have access to the data. You go to this URL. You can go download the report with a cryptographic signature that you can use to verify that I'm actually enforcing this at runtime. But they can't continue to go through this, you know, protracted back and forth. Then they change the rules. Now we got to restart the whole process again to get anything done. It's just it's untenable.
Yeah, so on the ACL side, right? Like we do support ACL role-based access. We do integrate with IDPs. Like enterprises have their own IDPs, but this problem is very complicated. Like Aaron said, like it has multiple levels, right? Like access level is one thing, but at the lower level is like you need to deal with all of that. So it's very clear that still companies have not figured out a complete solution for this. There's still a lot of debate about like for example, when I invoke an agent, it uses my credentials. But then if an agent needs to run by itself, who owns that, right? If it takes some actions, who's responsible for that? Which data can it touch when it tries to do something, right? How do you like set up those kind of policies? It's still in the infancy, basically. There are a ton of solutions there, a ton of proposals. One thing we see is like companies they have different kind of companies. Like some are completely okay going full speed, not care about a lot of things. Some are really, really paranoid, right? So the paranoid one go to a level where they want multiple on-prem deployments where there's complete isolation of data. Like they don't even want to rely on ACLs, right? So what each let's say a group gets their own on-prem deployment, throw the data there, and only those agents run there. But of course, then you are constraining what kind of use cases you can build by doing that to a level where you use ACLs, integrate with the IDP, like the identity provider you have, the same permissions there on data get translated into what you can access at runtime.
Yeah, and the description you're providing about having these completely hardware isolated through multiple deployments is effectively precisely what Opaque is providing, but much easier to deploy and manage, right? We're using these hardware primitives that are creating that hardware isolation to enforce governance, and it's all verifiable through the cryptographic enforcement at the hardware level. And I know you understand that a lot, obviously, but I'm sharing that for the audience, right? You can spin up these multiple air-gapped on-premise instances that has overhead associated with it, or you can employ Opaque or build your own software layer above it. The key thing I think about this too is thinking about sovereign AI, which is incredibly uh, hot, I guess, right now. Like hundreds of billions of dollars are being invested into sovereign AI. The missing piece for sovereign AI has been, doesn't matter what your zip code is where the data residency is, particularly with these AI agents. What matters is, can you verify, prove it like mathematically that the data stayed in that residency? So there's one way, like, okay, well, I can do it in air gapped on premise, but that's preventing AI from flourishing. Like AI wants to connect to all these sensitive systems and all this data. In order for you to get the full potential from it, you can achieve that, but you need this confidential AI layer, which provides the hardware enforcement that's verifiable, that enforces the data residency, enforces the rules, and provides the proof, right? So forget the data residency zip code. That's not kind of irrelevant. That's entirely irrelevant, uh, because AI agents just operate differently. Now, obviously, if it's in an air-gapped environment, okay, well, it's relevant, but then you're really restricting the value you can get from that.
Yeah, and I think that relates really well to a question that just came in. We talked a little bit about like privacy, security, configurability being drivers for looking at on-prem architectures. But the question that came in is there any situation where the on-prem is actually cheaper in some instances or provides better return on investment than looking at other deployment models?
I think we see a lot of that, don't we, Talat?
Yeah, absolutely. So I'll just give one example. So basically, there was a rumor that Facebook had the internal leaderboard about who consumes more tokens, basically, right? They were kind of saying that that translates to how efficient you are, and they had to shut that down because like that was no way an indication of how productive a person was. But in my opinion, what we're seeing is that with on-prem, the upfront cost is of course higher, but in the long run, that becomes cheaper because of the following reason. So your costs become very controlled, right? With a service provider, one, a lot of the model service providers right now are subsidizing the cost, right? At some point, like they're burning VC money basically. At some point, they're gonna pass that cost along to the end user. So whatever bills you have right now are just gonna shoot up, right? And those bills are already pretty high. We see cases where people run agents, they go get some tea, or even they keep them running all night, right? Those agents can just go haywire and they can consume so much tokens on something that will produce no good results that you can use, right? How do you constrain those, right? So the good thing about on-prem is that once you have the hardware, that's what you're going to use for hosting these models, right? So you cannot go beyond those costs that you already paid for that hardware. So this is becoming more and more common that we see that this is one way to constrain how much it's going to cost. Um, the second is like um, you don't so basically like you don't you can share the same hardware resources between different teams, and you can easily increase the utilization of your GPUs, right? Like you imagine, like yeah, your team is just running 10 queries per second. What about all the spare resources now you have, right? So when we partner with companies like VMware, they have a very nice way of ensuring your GPU utilization is high by sharing the same GPU across multiple workloads, right? So you play all of those tricks. So eventually the upfront costs are gonna get paid off very, very quickly. And we saw the same logic like 15, 20 years ago, cloud versus on-prem. Cloud is cheaper. People can immediately run everything. But if you look at your cloud bills, if you use those EC2 instances, instead you had your own machines, they would pay off very, very quickly. So we're seeing the same here.
Yeah, and we do have some
Yeah.
more questions that we'll reach out and answer individually. Really appreciate everybody joining the webinar today. I think before we leave, I'd just like to understand how can people find out more about Opaque Vectara, and do you have any exciting milestones or news coming up? And we can start with you, Aaron.
Opaque, sure. Opaque.co is where you can find more about Opaque. We've got a lot of great papers up there, videos, customer spotlights. Um, we do have news we're announcing next week, but I'll have to wait till next week.
All right, guys, tune in. What about you, Talat? Anything exciting?
Yeah, for Vectara, just go to vectara.com. With ton of information there, contact us. We'll be happy to provide demos, POCs. We do free trials. You can just sign up yourself. No credit card required. Try out the platform. But usually we see our customers more successful if they do the POCs with us because agents, they have like 500 things, knobs you can control, which models to use, what re-ranker to use, what chunking, so all that kind of stuff. When customers go with us for the POCs, we see much higher success rate. So do contact us and we can help with that.
All
Thank
right.
you all for tuning in. Thanks, Sean. Thanks a lot.
Yeah, thank you,
Yeah, and
everyone.
tune in and subscribe to the various newsletters. Get more information as I go along. Thank you so much, Talat and Aaron, and thank you so much for joining us today.